Okay, see Lindelof video. Just want to take a minute to analyze vertical and horizontal shifts in exponential functions. I am using a TI-Nspire CAS calculator, but that is not what this video is about. I'm just using this calculator to look at graphs. So let's start with this. Let's start with this blue function is 3 to the x power. That makes it an exponential function, right? And now I want to try to figure out how do I shift it left or right. And it's actually relatively easy, just a couple really strange things, but we can definitely do it. So let's do 3 to the x again. 3 to the x. What we're looking for is minus h here. And we can talk about why this works in just a second, but I do want to tell you that it has the opposite effect of what it looks like. So if I put in x minus 3, got to really stay with me on this. It seems like it would move that joint to the left 3 units, but it doesn't. Look what happens. It moves it to the right. So in the case of horizontal shifts, it actually works in a way that is counter to what we might think it would do. Let's try put in another one, see what happens here. So if I do that, I put in 3 to the x power, right? So here's 3 to the x power. If I add 3, look what's going to happen. When I subtracted 3, when I did x to the negative 3, it moved it over to the right 3. Look what happens if I do it the other way. So the purple function, or lavender, or whatever color that is to you, 3 to the x plus 3 moved it to the left. Super, super important thing to keep in mind, okay? Now, let's really quickly look at vertical shifts. Let's look at vertical shifts. So let me just get rid of this junk really quick. Now we're going to do vertical shift. Same parent function. That's the same function we're comparing things to. 3 to the x power, right? I just want you to really notice. Now I'm leaving the exponent, and I'm going to use my cursor and go to the right. You can see that cursor that you see in black and red is not up in the exponent. It's down, right? It's just a constant value I'm going to add to the whole function. That's called the k value. And if I add, this kind of works the way you'd think. If I add 2, then it lifts the function 2 from where it was. So it did pass through the y-axis at the point 0, 1. Now it passes through 2 up from there. So 2, 3. We good? Again, let's look at this one more time really quickly. That same function, of course, 3 to the x power. Moving out of the exponent, put in negative 3. Moves it down. So this is what we got to get from this. This is what we got to get from this. When we're trying to move the function left or right, it's counter what we would think. So if we have in the exponential way, if we have x minus 3, that's pushing to the right. It's really important. But when we do vertical shifts, it does exactly what we think. That is to say, if we put negative 3 out here, it drops it. Plus 2 lifts it. We good? Okay, you guys. Thanks for watching the video. I really hope it helped. If you have questions or comments, let me know. This is just weird stuff, and some of it is, frankly, it's just memorization.